Are we on? Hi. So I like to learn new things, and I know you say, and the point is, that's exactly right. I just turned 60 last week, and I'm so excited that I get to spend most of my life learning new things. And, you know, the extra challenges, Apple doesn't document any of this, so it's on us, right? And so what I want to talk to you about today is the intuition behind Combine. It's not so much a workshop on Combine as some of the intuition behind it. And let's start with an example. So here's a nice clicker. I designed it myself. Thank you. You guys are so easy. So the first way we might do this is with a view controller, and with the view controller, we might have an outlet that talks to our label, and we might have an action that gets called, and the action says, hey, can you increase the value, and let's change what's displayed in the text. And so the button is talking to the label, and you say, well, that's just MVC, and you say, okay, let's make this a little bit more the way we work on things now. And so I have my view controller. Let's add, some might call it a view model, some might call it a presenter. I'm not going to argue with you about it. But the view controller knows who its model is, and the model somehow has to communicate back. And we've learned that this is bad because now things are overcoupled. And so we introduce a delegate. And you've done delegate protocols for many years. And so the idea is that the view controller implements this delegate protocol, and so what the model is talking to, nice diagram, huh, is the delegate. It's not actually talking to the view controller, and that's your classic delegate pattern. And so here I have my view controller, and it owns the view model, and so I have my increase that gets called when the button gets pressed, and it says, hey, view model, increase the value. And the view model says, yeah, okay, but now I got to tell somebody what I've done, and so it needs a view model delegate, and in this case, it's going to be implemented by a class. And so my view model says, look, here's my signature, and it's always like this in Objective-C. Maybe we'll learn to shorten this in Swift, but it's view model did something, view model will something, view model should something. And in this case, it's view model did update int to something. And so the view model is going to send a message back to its delegate. And so the view controller implements this protocol. Wait a minute, aren't I supposed to be talking about Combine? I'm getting there. And so you know that the view model says, I'm going to set the delegate to be myself, and so we're doing that from the view controller, and then we conform to this method, and that's where we display the new int. And so the circle is complete, and all the view model has to do is it says, I got a delegate, at least I think I do, it's an optional, but if I have it, when the time comes to increase the value, I'm going to send this message back that says, can you update the int to this thing? And that's the delegate pattern. And we were so happy with that until about 8 years ago when Apple said, don't use it anymore. And then they shipped a lot of APIs that used it. And we thought, well, didn't you tell us not to use it anymore? And they said, well, we didn't mean us. What they wanted us to use instead were closures. And so in closures, it's the same idea, except inside the view controller, there's a closure. And so instead of calling the view controller back, we take this and we send this behavior forward. And so the closure gets sent to the view model. I don't get an ooh for that. Thank you. And so now the view model knows what it needs to do. And so it's the same idea. Here I am in my view controller. Instead, the view controller determines this closure. And so instead of setting the delegate and saying, call me back, I set my closure, and then I pass it on by saying, hey, view model, set your closure, your updater, to this thing. And so inside of this closed thing, I tell you how to update the label. The view model doesn't know about the label. The view model just gets this red box that says, you give me an int, I'll do what I need to do. And so over here in the view model, increase value just says, you've given me something, you've given me this updater, and so when you've increased my value, I'm going to go ahead and update it. Gosh, I love the did set in Swift. The did set in Swift says, whenever the model is changed, I'm going to call the did set. When I call the did set, the updater says, hey, the model's changed, display the result. And so when you take stock of this, you look at the flow at runtime, the user presses the button, the view controller then fires some action, it changes something in the view model by calling the increased value in the view model. The increased value in the view model increases the model by 1. So this is this one direction user action to state change. And since the user has said, okay, eventually the model's increased by 1, the view model says, oh, the model has changed. I call my did set, and that's when the closure is called. And inside the closure has this link to the label, and it just does it. And when you look at that, that's really the way we code in SwiftUI. The button doesn't know how to talk to labels anymore in SwiftUI. The button, just like Chris showed you in order to change anything on the screen, we have to modify state, and then somebody is going to react to that change in state. And so that's that same thing that we've seen. And so maybe we can do this in combine. Maybe we have a view controller and a view model. The view model has to be able to say, hey, I've changed. You can take me back now. Since the view model says, I've changed, it has some value. The way the view model says, I've changed, well, I don't know how it says that, but when it's changed, I want to do something. I want to increase my value by 1. And so the content view, this guy waiting for this message back, this content view is sitting here and it's displaying this text in this button. And when you press the button, you want to increase something. And so the button gets pressed and it calls the increase in the view model. And now I've got this observed object. I'm watching the view model to see when it's changed. And so the view model has to be able to tell me, hey, I've changed, and it does it with 2 tricks. It says, I am an observable object, which if you've been working with SwiftUI since the beginning, that name has changed. And it says, I've published this. This is the value you want to look for. And so that's how the view model says, I've changed, and as long as the text is dependent on something that has changed, it will reflect it just like we saw in the last session. So, I know, there are changes. Are you having any fun? I am. So, this is the changes. So you say, but Daniel, this talk was on Combine, and you're tying it to SwiftUI. Does it have to be tied to SwiftUI? And the answer is no. We can use UIKit. We could use the target action pattern, the thing we started with the button and the label. And so here I am in UIKit. You guys all happy with UIKit? You're never going to leave it? Psych. I know. iOS 13.2, then we will. And so I have my view controller, and my view controller has an IB outlet just the way we've done for so many years, and that's the label, and it has an action, and that's what the button calls. And the button calls this and says display text, and it picks a random number between 0 and 2. Why between 0 and 2? Ooh, we've got a big example coming. But what if we do this with Combine instead? And I got to tell you, I went to so many reactive talks, and this is the point where I rolled my eyes and said, this is stupid. Because we had this target action pattern, and we know when the button is pressed. Why are we doing this whole big thing? So just stay with me a second. So you can see from the space that this is going to be much bigger. I've got my outlet, I've got my action, and I've got my value now. Here's my model that I'm going to change. So instead of just the button getting pressed and saying, hey, change what the label is displaying, the button is going to say, hey, change what the value is that's going to be displayed. This is the big idea behind SwiftUI and Combine, is we're changing these values behind. And as before, we're going to announce that this thing is published. So when it changes, if anyone is listening, it's going to say, hey, here's the change I've done. So someone needs to be listening, or these changes aren't published. And so, for example, Someone needs to subscribe. So I have this value subscriber, and now I'm going to connect my subscriber to my publisher. It looks bad, but it's going to get better. Here I am in view.didLoad. I'm going to initialize my subscriber, and I'm going to say, subscriber, I want you to subscribe to value. And you cry, because there's a $ before value. The $ before value is related to property wrappers, and it says, I'm kind of subscribing to value, but I'm really subscribing, it's a binding. So it's to this thing that's sitting behind in the getter and setter. And you go, okay, I'll look it up later. And the subscriber says, here's my value, which is an int. And what I want to do when you give me my int is I want to set the label's text to be that. And you say, but I can't, the types don't match. The label's text wants a string, and I'm vending out an int. How do I turn an int to a string? And you were brought up right, so you know that's what map is for. Right? Map changes something to something else. But Daniel, map only works for arrays. Oh, if only. So what this says is take my int, return the int's description, and put that int description, the string version of the int, inside of the label's text field. Now, here's something you can think about. Do you guys know map for arrays? You've got an array of something, and you map it. It changes every element using the function that you have inside of map. Combined is the same way, except it's not an array of things. It's this 1 and this 2 and this 3 that we're flashing across the screen one at a time. So instead of them being inside a single array, they're coming at you one after another, separated by time, not by indexes. So it's that same map, it's that same pattern that you've seen before. So that's combined with the target action pattern. Instead of this simple version, right, where we just change the label, this bothers us for several reasons. Why should the button know that there's a label? Why should the button know that the label has a text? Why should the button know that the label's text expects a string? It's just too much that it knows. So we like to keep these things separate. And what combined does is it lets us build this pipeline of things that move from one to another. And so I start by just changing the value. The value is an int, and now I map that int to a string that I'm going to place inside of. Okay. Now, you should hire a designer. Here is a rock, paper, scissors example. And I choose rock, paper, scissors. The computer chooses rock, paper, scissors. It's green if I win. It's red if I lose. It's gray if we tie. Incredible. Should be part of Apple Arcade. Okay. So let's see how that might work. In this case, I have two outlets, one for my role, one for the computer's role. And so I have two published values. These are ints between 0 and 2. And now I have two subscribers that I have to connect. And every time I press that button, I find the next U value and the next computer value. And it's an int between 0 and 2. Now somehow I've got to convert from an int to a string. And so you roll 0, 1, or 2, but I don't trust you. What if your roll was outside of that range? So we guard against that and we return something else. If you rolled 0, 1, or 2, then we'll return rock, paper, scissors. And so now in my view.didLoad, we're going to wire these up. I have my U value. I map it using that function that I just had, and then I am able to display the rock, the paper, the scissors. So that's how we display. That's the same as we did before. But I also want to be able to determine who won. And this is harder because now I've got to compare U value and computer value and get some result. I've got to combine them. I know. Ooh. So I got to determine the winner between the first and the second. And if they're tied, I'm going to return light gray. And if I win, I return green. And even the code says if I lose, I return green. Oh, right, because I have to wrap around. So if I win, I return green, and if I lose, I return red. So there's green, there's red. So I have this winner subscriber, and I've got to wire these things up. So we wired up the things that displayed inside the two fields. How do we wire up this thing that combines them? And so I have these publishers, both of them, and I'm going to combine the latest value from the U value and the computer value. Now, there are other ways to do this, but just intuitively, this was a clean way of showing you. I'm just going to take, once I've rolled the latest U value, the latest computer value, and I'm going to combine them into something. What I'm going to combine them into is a tuple, and I'm going to map that tuple into a winner. And we saw how you mapped the winner. The winner took two rolls and said, who wins? And what it gave you back was a color. And since it's a color, I can assign that to the background color on the view. So we could use it for validation instead of this rock, paper, scissors. And you could just decide all sorts of things. And so I could have this value label, and I could have the subscriber, and I could decide when is something valid or not, and then I could display whether something's valid or not this way. I could have a success subscriber, and so my success subscriber, I look at the value, and I filter. And I said, this is only valid if the number I have is a multiple of 2. And so if it's valid, I'll show you green. Otherwise, I'll just leave it as red. What else can I do? I can take my subscriber and I can map it using whatever number I get, and so you don't do the red and green separately. I could say if it's a multiple of 2, return green, otherwise return red. And it's very flexible. Once you've got that, you're getting back a color. You can assign that color to the background color on the view. Are you beginning to develop sort of a feel for this? No, but we'll be polite to you and pretend we are. All right, quick volunteer. Quick volunteer. Thank you. Did you do from there? Thank you. Real loud. I give you an array. And here's our map. We're going to map on this array, and if it is a multiple of 2, it's green, otherwise it's red. Tell me what you get from this array. Red?
Red, green, red. I'm not, wait.
So I'm going to say you were absolutely correct. And I want to use this same map for things that come at you one at a time. So this is?
Red.
Very good. And this is? Good. See how much you've woken up? It's easier if they come slower, isn't it? Green. And so the idea is it's exact, thank you. Thank our volunteer. It's the same idea doing this to an array as it is doing it to the sequence of numbers that come at you one at a time. So these same things we know from arrays, from collections, this map and this filter and things like that, they are completely equivalent in combine. And so these tools that you've been saying, I don't want to learn map. Well, it's time. Okay. We have a publisher. That's this value that has been published out. We have subscriber, and the subscriber was where I took this thing and I set the text field or I set the background color. And in between is this thing called an operator. And this thing called an operator is really cool because it transformed one thing to another, and it did it by subscribing to value and by being a publisher to the next thing. So these operators sit in the middle and they say, I'm listening to what you give me, and then I'm publishing to what you want. I'm sitting in the middle, and so the operator is this guy in the middle. Now, you think we're done, but I have an obsession. I want to talk to you about map and FlatMap. And I want to talk to you using examples that they use this year at DubDub. And so at DubDub, there were 2 sessions, and in one of the sessions, there was an example that explained map or demonstrated map. And the idea was that there was a wizard who was in a certain grade. And this wizard in a certain grade was named Merlin. I know. And he was in grade 5. And so the idea was we're going to subscribe and we're going to somehow connect these things. And what's kind of neat is Apple has taken most of their widgets and things that send out these asynchronous events and wired them up with Combine. So you see this with things like Core Data, you see this with Notification Center, you see this as we were typing into a text field or pushing buttons. It's very easy for us to wire things together. And so the Notification Center is going to publish Merlin. Whenever Merlin changes, the Notification Center is going to publish that. Now, the Notification Center sends out notification objects. What I want to be able to take is my grade subscriber that figures out what grade I'm in. The grade subscriber wants ints. And so that's that same example. We need to transform a notification into an int. The types don't match. I can't just say, hey, you think that you emit notifications, and me, I want ints. I'm just going to connect us. And since the types don't match, we need to somehow use map. Now, are you okay with generics? Good. I have a publisher that is sending out notifications, and I want to transform it. That operator in the middle, that's really going to be the middle publisher, wants to send out ints. And we understand what happens with arrays. With arrays, if I have an array of notifications, and I want to map it to an array of ints, well, we don't write arrays that way. We write them this way, but this is just syntactic sugar. Then the trick is, give me a way of mapping a single notification to a single int. And if you give me a way of doing that, then map allows me to map a whole array of notifications to a whole array of ints. A whole array of notifications to a whole array of ints. So when it's time to look at the publisher map, it's the same F. It's the same F that worked for arrays, just like when he was transforming colors. The transform that he did so successfully for arrays was the same one he did for combine. Now, we just use map. This is the same F, but it's a different map. Every world has its own map, and so the map for combine is different than the map for arrays, but you are lifting the same function up. And so now I can take Merlin and say, look, I'm sending out notifications. In the middle, here's how I'm going to convert them. I'm going to take my notification and look for the new grade, and if it is a valid value, then I'm going to go ahead and assign it, and we even have a nicer way to assign it that you've seen. It's this nice notation here. And so that's all map is. Okay? Now, if you like $zeros, you can use this. If you want your code not to compile, you can do this. It's coming. This is the key path expressions as functions. It's very readable. It's coming soon. It's just not in and shipping yet. So let's look at FlatMap. How are you with FlatMap? We love FlatMap, Daniel. You guys just don't talk back to me, do you? Okay, so here's my FlatMap example. I have a function from string to int, that takes cat and says, well, there are 3 letters in it. So then if I map an array of strings, a cat is dumb, it maps to the array 1, 3, 2, 4. But what if I have a function on the diagonal? In fact, what if I have a function from string to an array of characters so that the word cat, the string cat, gets transformed to the array of characters CAT? Then string, an array of strings, a cat is dumb. If I map the F I get an array of arrays. You don't have time for that. So that's what FlatMap is for. FlatMap says get rid of that inner array and just have it still be an array of characters. And so we're going to do that in their example from DubDub. We have a function from data, not to magic trick, but to a publisher of a magic trick. And so I have a function from data to a publisher of a magic trick. Then if I used map, I get a function from a publisher of data to a publisher of a magic trick. And I don't even know what that means. So we need to flat map it. So without flat map, here's how that looks. I'm sending out a notification. I've got a new trick. And when I get my notification, I pull out the data from it. And then I use a JSON decoder to decode it. Did it work? Maybe. Maybe there was a problem with the JSON. Maybe there was a problem with something else. If everything works, I decode it. But if there's a problem, I have to catch an error. And now the problem is we've promised we're returning a publisher, so we have to return a publisher. And so we're returning a publisher that returns some placeholder magic trick. And it returns just this thing. So it's a publisher that returns this magic trick. And that's safe to use. I get a good magic trick, I get a bad magic trick, and I just vend out this placeholder magic trick. Except then I'm done. The catch gets called once and I'm finished. And so what we want to have happen is, as long as you give me good magic tricks, I transform them and I vend them out. And if you give me something bad, I look at it and I give you my placeholder, but I'm still listening for new ones. So you get my placeholder whenever I get a bad one, and you get the one you sent me. And so what I want to do is just keep going and not just end. And so I need this function that says, you give me data and I'll give you a publisher. And this function looks like this. It says, you give me data and I'm going to try to decode it. And if I can decode it, I'll publish that on. And if I can't, then I'll just send you a default one. So I need to embed that in a flat map. So we take this decode and catch and we put it inside a flat map, and it magically works. Thank you.
Thank you. Daniel, you can join us here. Chris is going to join us also here. We're going to have a short Q&A session. So take a seat, guys. So don't forget to ask your questions during the talk through Twitter.
Can I make a comment first?
Yeah, sure.
So Chris's talk was awesome, but one of my favorite moments in it was in the beginning where he took the bool and he called toggle. It was one of my favorite moments because toggle was added to Swift because of Chris.
Yeah.
Huge impact on developers all around the world.
So make sure to have your mic really close. Just one word to the classroom teachers. Make sure to join Mathilde down there, and you're going to be able to present your classroom in a few minutes, right after
I can go?
class. Yeah, you too. One word about us, like my name is Mathieu,
And mine is Simone.
So we are hosting and we're presenting and asking the questions to the nice speakers.
Are we going to redo the intro?
Maybe not.
No.
So those technologies have been kind of a big surprise for a lot of people. Like we were not expecting things like that from Apple. Are you happy with those new technologies? Are you happy with this shift in Apple paradigm?
I really am, and I gotta say, some people were very clear. Matt Gallagher had a blog post before DubDub where he called it almost exactly. It was just a beautiful exposition of what he sort of saw would be natural.
Yeah, that was kind of late, like for years. Like
Late?
Yeah, yeah, right. You never know, but like previously was more really confidential technologies. A lot of people were actually working with RX Swift or technologies, similar technologies. But now Apple has made that available to the whole public. And do you think it's going to be accessible to everyone? Like, isn't the learning curve too deep for some of us?
What I think is Apple's ecosystem is such that when Apple says, here's the way we're going, we go.
Yeah.
And like the Swift Package Manager compared to Carthage and CocoaPods, once it's a first-party thing, we go. And so there are people that are going to have to support back for a couple of years, but in a couple of years when people are saying, okay, we can support iOS 13 and beyond, it's so clearly the way Apple is carving out.
So I think another interesting thing is that the way, well, if you look at SwiftUI or Swift or whatever new technology, it's a little bit harder maybe for people who are already used to the ecosystem than people who are completely new. If you're a beginning developer, everything is difficult in the beginning, or at least I think so. It was for me, and then you learn something and you just do it, right? But if you know how to do, for example, animations in SwiftUI, or in UIKit, and then you need to do it in SwiftUI, and if you're like me, you're going to be frustrated because you knew you could do it and you cannot do it anymore. So you have to relearn and you have to change your mental model, and it's almost the same, but then quite different. And so, yeah.
Yeah, the problem is that you know how to do, so you do the old way, so you don't have like a real opportunity to learn and to like get the new paradigm.
Yeah. The next thing is that everybody is back to the beginning in a way. So I guess new apps will be able to have new juniors in the project because everybody will be like at the same level now.
Yeah,
we're
all junior.
To me, when I first saw SwiftUI, the code we saw from Apple, everything was sort of together. And now that we play with it and we see how different people are breaking it out and making it simpler to work with, it's much nicer. But I would like to see more examples, more documentation from Apple.
Yeah. A question which is related to what you were saying about like complexity and learning curve. How do you make sure the code base stays like readable for new people getting into the into a new code base? Because with those operators with lots of combine, I guess the understandability is that a word of the code base can be negatively impacted in some ways.
So I think Daniel's talk just showed that well, where if you use things like map that everybody knows probably by now, then that helps understandability. And then there are other operators in Combine that are more difficult to learn, but as you learn them, all of a sudden it becomes simple, and then the code is actually easier to understand. And I think it's the same with some of the things in SwiftUI. And understandability is really hard to define, I think, because it's very personal. And now that Apple has sort of blessed Combine, we're all going to learn it probably, and it will be easier to understand than manual things. But first, for the people who don't know it, it will be hard to understand. But once, like if you look at like 5 years from now, and maybe 8 out of 10 apps use Combine, then that's really helpful, because then you don't need to know like what framework is just Combine, and you know it and you've used it everywhere. So it's very difficult. Like in the beginning, it's going to be frustrating, but hopefully in the end, once we have a single technology, it will be easier to understand.
And I hear a lot from people that say, well, but this is way more intuitive, it's easier to understand. But I remember when OO came around and people didn't want to do that because that was too hard. And now people think, well, that's the natural way. There's no natural way. There are all ways of us partitioning problems.
OO is objective programming, right?
Object-oriented, yeah.
Oh, yeah. And so, as you were saying, like RX and other previous approaches were a bit hard because you were not sure that the new programmers would know that. And it seems that those new technologies can be adopted in existing apps gradually. And do you have some advices or some visions on how to actually embrace gradually in the code base, but also in the mindset of the programmers? How would you address that? How would you introduce those new technologies in existing apps?
So my job day-to-day job is writing example code, right? Like small example projects. So
Dream job, right?
yeah, and I love it. Like it's the best thing. I get to play around with these animations for a long time and see how it works. But I don't really have to work on scaling apps anymore. That's a very different problem, and that's like probably most people in the room know way more about this than I do. So I'm like, I would ask somebody in the audience because it's very hard to answer for me. Yeah.
So if you have tricks, then you can submit them to Twitter and add an hashtag FrenchKit and maybe Chris Adolf so that he can learn from you.
We've got two questions from our audience. The one being, what are the advantages of Combine over Eric's Swift and Eric's Coco?
The main advantage is it's a first-party API. People have complained that there are things that are in RX that aren't in Combine, and there are things that it doesn't seem that Combine engineers have considered yet. But the integration with the Apple APIs is a huge advantage, and it's just a matter of time before, unfortunately, things like this, it's just going to win.
Yeah, sure. And of course, the question that everybody asks, is all of this production ready? So if we like target an iOS 13 only app, can we go with it?
Or 13.2, right?
Yes.
Well, you just need to stay seated and watch Thomas's talk. He can tell you. He shipped a production app.
Yeah.
And I think it's, well, so if you do SwiftUI, you can totally ship with that, I think. We shipped a Swift app when Swift first came out, but you need to be aware, like things are going to be broken, you get a new version, you need to fix everything. So you don't have the same, like you have different problems. You have like less code and everything is nice and SwiftUI, but then you have these upgrade problems. When you do UIKit, you don't necessarily always have that, but then you need to write a lot more code. So it's really a matter of what you want. If you like being on the edge, if you really want to be sure and certain, like use a boring technology, it's way safer. But if you like having fun and you can in your job, and then why not? I would ship with it, but I don't really ship production apps so much as most people. So
You ship live coding with it, right?
So also something that Apple released, so this dub was huge, and collection views and diffable collections were huge this year. We don't see any of that in SwiftUI. And so there are some things that people think are important to apps that just don't ship with it.
So maybe one more thing to add to SwiftUI, if you're going to use it in production, you can always drop down to UIKit, so you can do certain components completely in UIKit. You can even use them straight, like as you have them, and you can sort of mix and match, so you can always fall back on that. It's maybe a little bit of comfort. It's not going to make everything easier, but at least it helps a little bit, I think.
And the integration is pretty nice.
But there's this production-ready question, but it's also about like, should I learn that right now? But is it wet? Will it change a lot? Because sometimes you learn a new technology and then it changes so much. I mean, Swift at the beginning, it changed so much that learning it from day one was probably not the best way to be really effective. How do you think it's going to change over time in the few first months or years?
So I think with SwiftUI, it's going to get sort of wider in a way. So there's going to be more components and stuff like that. I don't know how it's like in what ways it could go deeper, where like it's a different model. Still, like if the people who've been following along with the betas, like a lot of the names changed, like the observable object and so on. So a lot of there's still a lot of naming changes, but it seems like the concepts have stayed the same, even though now they work a lot better. Like they fixed a lot of bugs, but I don't know. Like I don't see. It's hard to predict. I don't have a what do you call it?
Crystal ball.
Crystal ball. Yes.
So I think one of the biggest things I look for is the same thing we saw in Swift, which was Swift changed, but even better, the tooling changed. And if you remember, dealing with errors in the early days of Swift were very hard. We're seeing that with SwiftUI, where. And it's partly because SwiftUI has changed so much that building the tools around it. So I think we're going to see better error messages and more helpful that way.
Yeah, and you were saying that the documentation is probably not like really great.
You're being
yet.
much nicer than I was.
I'm trying, but
I didn't say
sometimes it's
probably
hard.
at all.
And what, in your opinion, that's actually a matter of opinion, of course, is the will be the versioning model, the versioning approach? Because Swift was kind of Swift because it's a language, so you just have like Swift 2, which is not compatible backwards, but with a framework that's different. So how you make sure that how, in your opinion, will Apple make sure that they won't have breaking changes? Do you think they will have like combined two versions, not backwards compatible?
I imagine there will be breaking changes. I don't know, like but hopefully not. But I think there's a good chance that things might break. But if your app is big enough, maybe Apple will look at it before they push an update. But I think there's a good chance. At least my app broke. Well, not in the recent betas, but in the first few betas, it broke all the time.
But this happened in Swift 2. The transition from Swift 2 to 3 was very painful.
Yeah. Yeah.
And that was clear with the real version
But I think
number.
looking back, I think that's good. I think the Swift we have now is really good because they were willing to make those changes.
Absolutely.
And when Apple's developing SwiftUI internally, and then they get to see how it's used in the wild, I think they learn a lot from it. So I don't mind that they break and they make it better.
Yeah, it's just a decision where do you jump in. Just a quick question about the tool that you used, like this really old macOS 10 tool to graph the functions. Can you tell us a bit more about that?
Yeah, I use it for these kind of things because I'm bad at math and I need to visualize it. So if I see like, okay, here's a sign and it goes back to 0 to pi, I know, okay, I need to somehow compress it this way visually, and then I just try around until I find a good function. And I mean, this wasn't perfect, but it does the job. And yeah, the tool is awesome. It's called Grapher and it's built in, so you can just start it now.
Yeah, it's installed by macOS 10. It's in utilities, I think. Applications in utilities.
It's production ready.
This one is production. That's the only one that's production ready, maybe.
Actually, that's a nice how to say clin d'œil. So you're bad at math, you said, and there is a class from about math and functional programming this afternoon with Daniel. So yeah.
Awesome.
Wow, nice. Thank you very much, guys.
Thank you.
Thank you for your time.